Welcome to Study Loop.
So in this problem, we are given with a reaction equation of this one, where chlorine is reacting with water to produce hydrochloric acid and oxygen gas. So we are given the value of Kp for this reaction and also given the value of T, or the temperature, in degrees C, which if we convert it to Kelvin scale just by adding 273 Kelvin, the value will be 753 K. So before we start solving the problems, we'll first write down the expression for Kp of this reaction. So the expression of Kp for this reaction will be the partial pressure of the products, that means PHCl, and since we have 4 of the HCl, the power here will be 4 times the partial pressure of O2, and in the reactant side, or we will have we have 2 chlorine, that means it will be PCl2 and this raised to power 2, since we have 2 chlorine, times partial pressure of H2O, and we have also 2 H2O, that means power will be raised to 2. Now in the first part of this problem, we have to find out the Kp value for this reaction, which is basically the reverse reaction of the reaction given. So here 2Cl2 and 2H2 are reacting to produce 4HCl and O2. In this reaction, 4HCl and O2 is reacting to produce 2Cl2 and 2H2. And for such reactions, as we know that the Kp of a reverse reaction is basically the inverse of the Kp of the forward reaction. That means the Kp value for this reaction will be 1 over the Kp value of this reaction, which is 0.0752. So we just put 1 over 0.0752, and this will give us a value of 13.30. So the Kp value for this reaction in part A is this. Then in second part of this problem, we have to find out the Kp value for this reaction. So if we write down the expression of Kp for this reaction, we will find, so partial pressure of HCl raised to the power 2, since we have 2 HCl here, then times the partial pressure of O2 raised to the power half, and in the denominator we have 1 chlorine, that means partial pressure of chlorine times partial pressure of H2O. So now if we take this half as a whole power, we will write down this as partial pressure of HCl. So we are putting this half as whole power, so it will be partial pressure of HCl to the power 4 times partial pressure of O2, and in the denominator we will have partial pressure of Cl2 raised to power 2 times partial pressure of H2O raised to the power 2. So we have written this in this form because this is the same reaction as this one, but just the coefficients are different, or the total reaction here is basically divided by 2 to get this reaction here. So that means this is basically the same reaction but with the different coefficients. So if we write down this reaction in this form, so from here we can easily see that this is actually the equilibrium constant in pressure expression for this reaction. So you can see that this is basically we have written here in this form. That means we can write down the Kp value for this reaction as the Kp value for the reaction given. So if we term it as Kp1, that means this is basically Kp1 whole to the power half. And that means if we just square root the Kp value of this reaction, we will get the Kp value for this reaction. So we just do this. So we just um, put the value 0.0752, which is the Kp value for the reaction given, and we put a square root or half as a power, and this will give us the value for the Kp value for part B, and it will give us a value of 0.274. So this is the Kp value for the reaction given in B. Now in part C, we are asked to find out the value of Kc for the reaction in part B. So again, we know that there is a relation between Kp and Kc, which is Kp equal to Kc RT del N. So we know the Kp value of that, which is we just calculated this, and we know the value of R, which is the universal gas constant. We know the value of T, which is given. We have to find out the value of del N. So to find out the value of del N, we just have to, we know that del N is basically um, the difference between the number of molecules of products minus the number of molecules of reactant. So here the del N will be 2 plus half as the number of molecules of product minus the number of molecules of reactant. We have 1 plus 1, 2 reactant. That means 2 plus half minus 2. That means the value of del N here is half, or is equal to 0.5. So now we know the value of del N also. Now if we just rewrite this as this Kp over RT whole to the power del N, here the value of Kp we have just calculated here as this 0.274. So it will be 0.274 over so the value of R is 0.08206 times the temperature, which is 753 K times 753, and the power is raised to del N, which is 0.5 or half. And if we just solve this, we'll get the value of Kc for this reaction, which is 0.0348. So this is the value of Kc for the reaction given in part B.